All right, so now we done the basics. It's basically we've done everything we need to do. And just show you some more examples. We're gonna go through some more examples so you can get some more practice on your own with me, and then you'll get some more examples and you'll be able to check your answers. Hopefully, you'll get this down packed. All right, so we're gonna look at the example of y equals -2 square roots of x. See, what I'm doing right now is I'm giving you different examples so you can see what each part does. We noticed on the last one, if we had something inside there with x being added or subtracted to it, it moves to left and right. So let's see what happens when we put this -2 on the outside. What does it do to the original one? So we're going to follow the same process. All right, we're going to make us a table, pick some x and y's that we can graph. Um, Notice in this one, we need to figure out what numbers we can use before we can do that table. Well, this one's pretty simple because on the inside I just have x, and we just know x has to be greater than or equal to 0. So I know the smallest number I can use here is going to be 0. So we'll start at 0 on our table. Remember, we want to pick numbers that are perfect squares that we know are going to make it nice for us. So we can also pick, if we plug in 0, we're going to get 0 out. Okay, so now I also want to plug in 1. So that means I'm going to get -2 times the square root of 1. Well, the square root of 1 is just equal to 1, so we get -2 times 1, which is just -2. Alright, and then I want to pick 4 because I know that's my next perfect square. So now I'm going to do y equals -2 square root of 4. Well, we get y equals -2. Square root of 4 is 2, so -2 times 2, so y is equal to -4. Alright, so now we're going to go ahead and graph it because now we got 3 points we can use. We could use 9. Let's go ahead and do 9, just get another point there. So we're going to use 9. And then so we plug in 9. I'm not going to show the work here. I'm going to just do it. If you plug in 9, you're going to get 3. And then you get 3 times -2, which is -6. So now we can go ahead and make our graph, which I'm going to do right here. And of course, I don't have 9, so we're not going to put it on there. So we put a dot at 0, 0. All right. Then we're going to go to 1, -2. Then we're going to 4, and then -4. And then so we know our graph looks like this. And it starts to bottom out right there. And so this is what our function looks like, and it goes on for forever there. So we'll figure out all that other stuff. But right now, we want to notice something. Okay? We want to notice that, hey, our original one was up here like this. Notice that we're down here in quadrant 4, and we notice that our new one doesn't look like that. The reason it went this way is because of this negative. All right, this negative, if there's a negative in front of our square root, that means it's going to flip it across the x-axis. Across the x-axis. Okay. All right, it's going to flip it across the x-axis. All right. The 2 made it increase a little bit steeper. Is what you could call it there. Because our original one, we would be at 0, 0. And then our next point for the original will be at 1, 1. And then we would be at 4, 2. Well, notice here, okay, we're at 0, 0, but then we're at 1, 2, and then we're at 4, negative 4. So we're increasing more there. All right. And so now we can go ahead and fill out all the rest of our information and say that, hey, we'll start with the domain. Well, my domain is all my x values I can put in. Well, the smallest one I can put in is 0, so, and since I can include 0, I'm going to put it right there. And then my x values go on for forever, so therefore it has to be positive infinity since we're going to the right. My range, now I'm looking at my up and down, um, which is my y values. Well, I know I got a top one, right? So I know I'm going to come from the bottom, so that has to be negative infinity. And then I stop at a top point of 0. And so bracket 0 for this one for my domain and my range. Now looking at it, I need to know if it's increasing or decreasing. Well, if I look from left to right, I'm going down still, so I'm going to have to be decreasing. So we don't have an increasing interval, we have a decreasing interval. And the interval that is decreasing, well, it starts at 0, and it's going to be decreasing all the way through infinity. It's going to continue to decrease going to the right no matter what. Make sure you put a bracket here. All right, and then our last one that we need to know is, oh wait, we need to do x and y intercepts. X-intercept is easy because it's where it hits here. Well, it's the point. It's where y equals 0. Well, y equals 0 at the point 0, 0. Y-intercept is where x is 0. Well, x is 0 at 0 also. So my x and y intercept for this case turns out to be the same, makes life a lot easy for us. How does it differ? So I'm gonna just write differ here. How does it differ? All right. Well, we know that it was flipped across x-axis. All right, it was flipped across the x-axis, and it increased rate by 2, I guess is what we can call it.